a point. And that's why sometimes, if you have something like a line in your compound where you hang your clothes, you find out that it's because of this thing we're going to learn today. That's why those things, when you hang your clothes there, they don't fall down or the line will not cut. So we're going to be seeing why these things are possible. So one thing about equilibrium of two forces are acting at a point. Let's just look at what I have on the board here. On the board, I have two forces acting at a point. We have force 1, force 2, and what? The other one is the one we call the resultant. Now, how do we identify the resultant force? Now, when two forces are at a point, acting at a point, the diagonal which bisect the equilibrium, the parallelogram, sorry, I said equilibrium, bisect the parallelogram. That means, you remember, with this kind of shape, we can call it a parallelogram. Let me just give you another picture of what we mean by that. So we say we have something like this. This is the bisector, which is now this bisector that bisects the parallelogram is giving us what we call the resultant. Now, what is this resultant? Resultant is the one single force that can act alone, like the two, as if two of them join together. So this one is our force 1, and this other one is our force 2. So this is our resultant. So in order to get this thing done, well, the first thing I'm going to show you here is how to get the formula. Remember, when you look at it very well, you can look at it in the angle of, we have a triangle, we have a shape like this, we have a AB, and then we have C, and then we have D. So if we are looking, let's say we are looking for this R. If we are looking for this R, remember the cosine rule, then we have R squared will be equal to F1 squared plus F2 squared minus 2 F1 F2 cos 80 minus what? Theta. That's the angle joining them together. This angle here is the one we call theta. But then whenever we are working on this, we concentrate, we normally use this angle here because of the shape, the position of this resultant. So that is 180 minus what? 180 minus theta will give us the angle that we have here. So with this now, for us to get the formula that can help us find the resultant easily, what we're going to do now is that, remember, this will give us negative cos. Remember, this will give us the negative cos. This one will give us 180. Whatever we have here, let's call it alpha minus cos alpha. Whatever will be the product of this 180 minus what? Theta. Then we have our 2 F1 F2 minus what? We have our F what? F2 squared plus what? F1 squared, F1 squared to give us R squared. So with this now, this cos here, multiplying what we have here, we change it to what? We have plus. We have F1 squared plus F2 squared plus what? 2F1 2F2 cos what? Alpha. Cos alpha equal to R squared. Equal to R squared. This will give us the basic formula for calculation of the what? The resultant force of two forces. Resultant force of two forces acting at a point. So now what we're going to do next is to just try to use this thing to solve one problem. We're going to use it to solve one problem so that we'll be able to digest whatever we have. So now, say that two forces of 30 Newton and 50 Newton acts at a point, and the angle between them is 60 degrees. Find the resultant force and its direction. So when we look at this now, I say that the two forces, let's just have a sketch of it. A sketch of the two forces. We have one which is what? This one is what? 30 Newton, and the other one is what? 50 Newton. Then angle between them is what? 60 degrees. So now the resultant force should be the one going in between them here. If it's that one, then what we should have here, let's go ahead and get something that will look like this. So what we have is this. So this is also equal, like a parallelogram is also equal, and this other end is also equal to what? 50 Newton. So now with this now, based on our formula, the formula we have just established, we have the resultant. To calculate the resultant, what I'm going to do here? What we're going to do here is what? Remember, arrow squared is equal to what? That is 30 squared plus 50 squared plus 2 times 30 times 50 cos. What will be our cos now? We have our, it will be brackets. We'll get our 180 minus 60. That will give us, what we have will be, this will give us 900. That will give us 900, I think so. 30 squared 900 will give us 900 plus this one will be, is it 2500 squared 2500. We have 2500. Then we have plus now. Remember, according to our formula, we have equal to f1 squared plus f2 squared plus 2f1 f2 cos what? 80 minus theta. So these other ones we have here, let's quickly run it. Times 30 times 50, we have what? 3000. Then our cos here will be cos, I will go by 60. The equivalent of it should be 120 here, but the equivalent of it should give us 120 equivalent is this. So, and it should be negative based on what we have already established. It's going to be what? Positive. So what are we going to do next? We get the cos 60 is equal to 0.5 times 3000 plus these other ones, adding up together, 900 plus 2500 will give us 3400. So 3400, this multiplying, we have a 3 divided by 3 multiplied by 0.5, we have 1500 plus 3400. All these things are equal to what? Arrow squared. Then what do we do next? We sum them up. Since they are plusing, we have 300 plus 1. That will give us 4900 equal to arrow squared. So arrow squared, what are we going to do next? Arrow squared equal to 400. Get the square root of this. Square, we have 70 arrow equal to what? 70. That's 70 Newton. That is what we have, is 70 Newton. Now to get the direction, looking at this, you find out the force will be tilting towards the what? 50 Newton. To do this, we can use the sine rule. We are going to use the sine rule. From here, we have our this angle. This is for that, and then okay, the direction has to do with this. This very one here, we can call it alpha. We can call it alpha. Now the alpha will be sine alpha over what? 30 Newton equal to this other place which is a sine 120 all over r, which is 70. So when we cross multiply, what we have will be sine alpha 30 sine 120 all over what? 700. So what do we have here? What we should have will be sine 120 times 30 divided by 70. We have the value of what we have will be 0.3712 alpha. So to get the equivalence, the real angle we have, so the direction will be equal to 21.8 degree towards the direction of what? The 50 Newton. So this is where we're going to end for today. If you are joining for the first time, we encourage you to subscribe to our channel, and then I want you to like, share, and if you have any question, leave it in the comment section where we will always attend to you. See you in the next video. Thank you.